Okay, recursively defined sequences. I'm glad that I don't explain things using this terminology, but if you were going to look it up in a book, this is what it would say. A process in which each step of a pattern is dependent on the step or steps that come before it. So what that really means is that any sequence that you have, if you grab a random term out of it, that term, like let's say the 8 in the little list I have here, that term, you could think of it as coming from the term before it, the 5, except you do what to it? Add 3. You just add 3 each time. All right, so there's different kinds of sequences. There's arithmetic sequences. That's what we're doing today. Arithmetic are the kind where you add something each time or subtract something. That's considered adding a negative. So either way, it's adding. You know what I'm saying? You're either adding a positive or you're adding a negative. So it's either going to go up or down. When it goes up or down based on an adding an amount, that's an arithmetic sequence. That's the kind we're messing with today. The hard part is today is not like the sequences. They're not really tricky ones. You know, now I'm in algebra 2, so therefore we get really hard sequences. It's not that. It's we learn to write them in a really funky way. And I think you'll understand it. Okay, if I have my list 2, 4, 6, 8, 10, u sub 1 and u sub n are important for you to understand. U sub 1 is the first term. Okay? U sub n is any term, and I don't know which one it is. That's why I said n. If I'd known it was the second term, I'd have called it u sub 2. You see what I'm saying? U sub n is any term. U sub 1 is the first term. So what's u sub 2? In this case, it's 4. It's the second term. What's u sub 73? It's the 73rd term, right? Okay, so this is just the first term. And u sub n, when I pick that, I'm saying I don't know which term it is. It's any random term. But I can tell you this. If I pick the 8 to be u sub n, then the one right before u sub n would be u sub, what do you think? N minus 1. Very good. And the term right after it would be u sub n plus 1. Good. Okay. So that's how we're going to define our sequences. What we're going to say is what we start with, u sub 1, it's the first term, and then we're going to say any random term is given by the term in front of it. Let's get rid of this guy. The term in front of it, and then you do something to get the next term. So in this case, what do we do to get this 6 to turn into this 8? You add 2. So here is the official way we would write this sequence. We'd say u sub 1 is 2, as in the first term is 2. And u sub n, any random term, can be given by u sub n minus 1, which means any random term except the term right in front of it. You know what I mean? It's the term right in front of this one. And then we do whatever we need to. In this case, we're adding 2 each time, right? That's called the common difference. So that goes here. And then we say where, this is saying my domain now, where n, the number of the random term, can't be the first term, because if it's the very first term, we don't have anything before it to look at. So we have to only do this where the term is the second one or farther or later than that. All right, that's a lot to absorb at once. I think you were probably following with me through the beginning of it, and you probably got a little lost as we moved into it. But this is the part, I don't know why that's blue. I guess it's blue because it's different. It's the domain. The part that I just wrote there, that's how you write any formula. You always start with u sub 1, and then you always say u sub n is given by u sub n minus 1. What it's saying is any term is given by the term in front of it. And then you always do something here. And in this case today, we're only talking about the arithmetic kind, which is the kind where you add something each time. And then you always have to put something here, which is what again? The first term. And that's all there is to it. So I can take any sequence and just slap in this boilerplate like that. That always has to be there. And then I'll write in green what I have for this problem. It starts with 2, so I put a 2 there. What do I do to get each successing term, the term after the next one, etc.? I add 2 each time, so it's plus 2. Let's see if you can take that and write a formula for this one. Give it a try. I'll pause while you do. Okay, so I gave you all the boilerplate there. All you had to do is fill in the blanks, and u sub 1 is equal to what? 8. And u sub n is given by u sub n minus 1, and then what do you do here to get the next term? Plus negative 2. And it'd be okay with me if you just said minus 2 there, as long as you understand that this one is going down 2 each time. All right. Now, this is the part usually that people don't really understand. Would you please put a circle around that and write domain? Domain means the inputs, the things that you can put into this formula. And where is our variable? Did you ever see u changing? No, u is always the same. It's only the number down here that's really the variable. And that's the n number. See, sometimes it actually is an n, like here. Here it's n minus 1. But that's the thing that can change, those little numbers. And those little numbers can't be 1. Why? Because we cannot use this formula to figure out what the very first term is. You know what I mean? Like, I can't look at the 8 and say, oh, I know what was in front of it. Yeah, you could theorize that it must be like 2 bigger than 8 and it must be 10, but you don't really know what's in front of it because it's the first one. But everyone after that, all these terms, they all have something in front of them. And that's what a recursive formula does, is it looks back at the term in front of it, n minus 1, and says, what did I do to the term in front of it to get that? All right. So let's look at this one. See if you can write the formula for that one. Okay, so how do you start? U sub 1 equals 5. What do you always say next? Equals. Good. In this case, plus 5, because they add 5 each time. And what's the domain? N is greater than or equal to 2, and it's always 2 if this is 1. If you start with u sub 1, then you're always going to use the domain that it has to be the second term or bigger, because otherwise the formula won't work. The formula can't figure out what happened before the first term. All right. Given a formula, like if I said, here's the formula, tell me what the first few terms are, these are even easier. So what's the first few terms? 7, and then what? Add 4 here, so you got 11, and then that's all there is to it. Those will be really easy. Okay. There's one question that kind of sums up, and then at the end is going to bring up a reason why we need to use the calculator. So I'd like you to try to answer this question. I'll pause while you do. Okay, so what do you guys think the most common mistake answer is for what is the common difference? What do you think the wrong answer is that I see a lot? 7. What is the right answer? Negatives. Good. Okay, what's recursive formula? Well, you always start with u sub 1 equals 20. U sub n given by u sub n minus 1. And then you do, what do you do to get the next term? Minus 7. And then where n is greater than or equal to 2. All right, what's the 11th term? Well, we got 1, 2, 3, 4, 5 terms. It's going to be kind of a pain in the butt to go out that far. So let me show you how to do that on a calculator. All right, so grab your calculators. I'll pause while you do.